Project Geothermal Energy in Special Underground Structures, supported by EU program Horizon 2020, contributes to the European Green Deal by supporting research in the area of clean and renewable energy. The project supports the transition towards a modern, resource-efficient and competitive economy. The research of geothermal energy usage requires a combination of several scientific areas, such as geology, civil engineering, material research, as well as measurement, control and communication technologies. The control and monitoring system working with actual data from sensors, the environment, as well as with predictive or historical data, an essential subsystem needed for the efficient operation of heating and cooling applications based on geothermal energy.
Der nachhaltige Umgang mit den Ressourcen unseres Planeten ist unsere gemeinsame Verantwortung. Wir als Eins steigen aus der Braunkohleverbrennung aus und setzen auf Erdgasmotoren, eine Übergangstechnologie. Weiterhin sind wir offen für neue technologische Entwicklungen, um den CO2-Ausstoß und insgesamt den Ausstoß von klimaschädlichen Gasen deutlich zu senken.
Hello, my name is Dieter Weise. I'm a scientist at Fraunhofer IWU and Deputy Director of the Fraunhofer Innovation Platform in Ostrava. I'm leading the work of Fraunhofer IWU in the project GeoUS. Our target is to increase the use of renewable energy and to reduce the CO2 emissions. For this purpose, we are building a network of excellence together with our partners, and we are transferring our technical know-how in a new area of application.
University of Vaasa has participated in the GeoUS project as a partner. We have provided training in the field of geothermal energy as well as in scientific skills. The training has been done via webinars, workshops and summer schools. In addition, we have hosted internship of 2 early-stage researchers from VSP. We have made together several publications and founding applications too.
Geothermal energy is undoubtedly a promising source of renewable energy. Shallow, low-potential geothermal systems, gaining energy from the earth and solar radiation, are widely applicable for a range of climatic and geological conditions. There is no general shortage of thermal energy on the earth. Unfortunately, it is non-uniformly distributed in space and time. Therefore, we need to exploit thermal energy in winter, for example by borehole heat exchangers, and store heat from air conditioning in summer, thus restoring rock mass heat budget. In addition, in circular economy, we should reuse waste heat from industry in our coal mining region, for example, heat from burning waste rock dump or mine water.
After decision to design a system where the source of thermal energy is the rock environment, it is first necessary to verify the quality of the rock environment and start close cooperation with the building designers. When geothermal energy is required to heat and cool the building, the heat losses and gains of the building must be taken into account. The parameters to be determined for the rock environment are mainly thermal conductivity and heat capacity. In the case of large installations consisting of more than 10 boreholes, it is advisable to rely on the measured values obtained from the thermal response test. An essential part of the design of the heat exchanger is also the definition of the areas where the heat exchanger can be installed. For larger systems, heat exchangers should also be split into several circuits to minimize the energy required to run the system during times of low heat demand.
Hello, my name is Matthias Demmler and I am a scientist and the department leader for sheet metal forming and material characterization here in the institution. We are standing in front of a high temperature forming system. This system is able to form out materials like titanium, titan aluminides or molybdene. And these materials we want to use in the future in innovative energy systems for high temperature applications.
Hello, my name is Alexander Pierer. I'm scientist and group leader for measurement technology and condition monitoring here at Fraunhofer IWU in Chemnitz. We have developed intelligent predictive maintenance systems for the optimal maintenance of presses and other machine tools. Now we are transferring our know-how to heat pumps, storage units and energy systems to make their maintenance easier and more cost-effective and to avoid downtimes.
Hello, my name is Peter Scholz. I'm scientist and project manager at Fraunhofer IWU. Modern facades are often two-dimensional and poorly used in terms of energy. I changed this by using our incremental forming technology to produce facade elements cost-efficiently and assemble them into three-dimensional facade images. In addition, we integrate hidden channels for the solar thermal use of facades and increase the overall energy balance of buildings.
Distributed temperature sensing DTS method is based on scattering of light in glass fiber cable. It's a temperature measurement method where optical fiber act as a linear sensor. A measuring device sends short optical pulses, so laser light is going there. A light pulse encounters different scattering during its progression. A certain type of scattering, Raman scattering, is temperature sensitive. Measuring device determines the temperature at a certain point in the optical fiber with respect to anti-Stokes and Stokes photons and an optical pulse running time.
As a large regional energy supply company, we have, of course, a big responsibility for the people who live in the region. And that's why we are working very hard every day to use new technologies in the future to be more environmental friendly in our production. And as a result, from our early exit from the lignite combustion, we will save more than 60% of CO2 output in the future with the new gas-based technology.